background set behavior. That is stuff that always processes all the time anyways. That stuff's going to process every time we perform an action, and we don't want it polluting our data set. So first we make a background layer. That's an incremental coverage set. Now we'll do a second set where only the behavior that's not already represented in the background layer will be collected. And that we can differentiate the noise from the stuff of value. So here's just a quick diagram of how this would work. If this was a static control flow trace on the left, then I perform some action, then these coloring would occur here, and these are the functions that have executed. And I can continue this process for different actions, and the new colored regions are each of the various actions and their corresponding behaviors. So I'm going to use World of Warcraft as my example. It's a very good example because it's very large and it does a lot of stuff. It's very dynamic, and it's also something you can't graph statically. It's just too big. There's 12,000 functions, 82,000 call references, and over 37,000 symbols in the version of World of Warcraft that I reverse engineered last week. So let's drop that on our canvas and see what it looks like. Now that is nodes and edges. There's so many edges that they've blocked out the screen to the point where it looks like we're staring at a star field. Entirely too much information. That's the background layer. Now I'm going to I hook up to World of Warcraft. This is a debugger, by the way, so we're actually attaching as a debugger, and we're collecting control flow information using breakpoints on the entry point of every called function. So that's the way under the hood that we're operating the system, okay? So we're getting a whole stream of events. They're coming over a TCP channel. The debugger and World of Warcraft are running on their own machine, and this tool is actually running on my laptop at this time. And it runs in, and there's a big stream. This, to be honest, takes about 5 minutes to settle down. And that's what we end up with. I call that the Death Star. This is actually just the general purpose handling of stuff going on in the background. Now, I'm logged in with a character, so we're talking about network activity, rendering functions. I also decide I should probably get some of the noise for the packet or for the mouse handling out of the way, so I just drag the mouse over the screen a couple times. And then this settles down in about 5 minutes. I think we have about 2,600 different nodes in there. You can notice the actual background layer is actually toggled off. I don't know if you can see that in the screenshot, but there's a color. There's a little blue pin or a little clear pin, depending on whether it's toggled on or off. All right, so this is still a graph that's entirely too large to interact with. So the next step is we're going to create a new layer, and we're going to just perform some more mouse operations. This time I'm going to mouse over the casting bar, let some pop-ups appear, touch the little map in the corner. I'm not going to click. I'm just going to move the mouse. Now remember, those nodes that are executed will only be added to the graph if they don't already exist in this background layer. And that's what we end up with. Now we're talking about a manageable graph. And I actually have now on this graph miscellaneous mouse handling. The graph complexity is at the point now where I can very easily interact with it. We have about 180 nodes on that graph right there. Okay. Yeah, let's do a demo reel of that. Now, I actually can't see my screen here, so I'll be a little clumsy getting my thing to run here, so just forgive me for that. It's going to be a real pain in the ass, too, I can tell. Demo. Is that demo reel 1? Okay, good. You'll have to help me. Is that the WMV right there? Okay, good. All right, let's see if it'll work. Okay. All right, so here's all the layers I've collected for World of Warcraft at this point. I've cast a bunch of spells. I've clicked on NPCs. I completed a quest. I'm just showing you how the tool operates here. What I've done is toggled off another layer, and I'm refreshing the graph. I'll zoom in here a little bit. Okay, so I think what we're looking here is all the code that executed when I cast a flash heal spell, which is one of the spells I can't remember what character class I was, priest, I think, or paladin or something. Okay, so then I actually cast a different spell, just a regular heal, and it actually has a lot of the same, overlaps actually a lot of the same functions, which makes sense because they're both heal spells. So I toggle that on and refresh. I change the layout a little bit. Let's go ahead and change the layout again here. Okay, that's a better layout for this particular. I'm going to zoom up in the corner. You can see that the actual regular heal, which is a darker green, is all clustered together on the corner of the graph there. And in case you're wondering what these blocks are, I'm going to turn on labels. The blocks represent individual functions in WoW. So if we zoom in, you can see that actually those are the labels, subroutine labels for that. And I'm going to change the layout again and zoom down. Hopefully Hopefully you can see that. We have the function labels there for the heel spell. So if I go to those locations in dark green, those are actually handling the heel specifically, not the general purpose processing around the heel. Now this is called a circular layout. This one is my favorite layout of all because it has a tendency to show class relationships really well. You see the two clusters are actually connected. This cluster down on the lower right is actually connected through this link right there up into the other class. So you actually have not, we've just by visually doing this, we've actually identified one of the coupling points between two distinct sets of logic in the program. And again, I haven't had to do any disassembly at this point to figure this out. I actually don't like having labels on though. It looks prettier to me when I just have the regular little blocks like that. I think that was the end of the demo reel for that. Yeah. Okay, let's go back to the slide presentation. Here. Okay, so let's talk about some of the things we can look at on the screen when we're doing this process. These tightly coupled groups have a tendency to be classes, as I was mentioning. These two groups here that are in red are me interacting with the cast bar. You can see another tiny one down on the lower right, or lower left, that is, and you can see that there as well. I haven't clicked on anything, so I haven't actually cast any spells in this particular screenshot. So what, again, I'm doing is reducing out or removing from the sets all the information that's just related to the general processing so that when I get down and actually cast some spells, I can actually identify just the functions of interest. Some other interesting patterns that we can see. If you can look there, you see we have a kind of a bluish-green set. It calls out into a red set, and it goes several deep. Those are call stacks. If you were actually to set a breakpoint, how many here have used debuggers? Okay, so you know if you set a breakpoint, you can just go see a call stack, right? Well, there on the red node on the end, if you were to set a breakpoint there, you would see each of those links coming in. So that's actually a call stack headed out on the link there. Now, the mouse handling functions are in green. You can see that we branch out into the red, and the mouse handler is calling into casting bar functions. So these, again, are pretty generic casting bar handlers. So these links between two different colors are very important. That's usually a point where something's been parsed and it's actually branching out into a different file or a different class, and it's doing something specific with the new behavior. Now, that is general casting bar interaction. I'll show you some specific casting of spells here in a moment. The utility function called in a loop is also kind of an interesting pattern. And off to the left here, we can see recursion. You can see how the block calls bit on itself. So we have a recursive function stands out right away. Oh, and then, of course, the two classes are intersecting slightly through that middle node. That's another place you'd want to start looking if you're trying to reverse engineer. So if I want to jump into actual disassembling, that might be a good place to start. All right. So, cast a flash heel. That appears in a new color, green. You can see a tightly clustered group up on the top. That's all the stuff dealing with the flash heel spell. The little thing that shoots off to the side there is the integration between the flash heel and the general casting bar. And we can see there would be the place where maybe the casting bar logic has determined what button was pressed, looked up the appropriate thing to do, and then branched out into the actual specific processing, which is then another group. Again, no disassembly at this point in time. Now I cast another spell called Fade. Now Fade is a totally different kind of spell. It actually interacts with the screen. Your character kind of disappears into the underbrush. It's just a different thing. And again, in the Fade group, we get a whole new cluster dealing with Fade. So these functions here in blue are all the things related to the Fade spell. Now I have two versions of the Fade spell shown here, just to illustrate a point. On the left-hand side graph, I have all the different layers toggled on, so you don't see a nice defined structure for Fade. On the right-hand side, we get a nice defined structure for Fade, but we've removed the visibility of certain sets. So what I'm trying to illustrate to you here is that toggling the visibility of sets is very important for revealing structure. Because the more sets you have visible, the more cohesion you're going to see between nodes, and it tends to muddy up the display. The information is valid, but we only want to look at what we have to. So toggling off the layers is very important. So on the right-hand side, we have only enough to show that Fade structure. Okay, so that's basic partitioning. Now, this can be applied to malware, this can be applied to game hacking, this can be applied to any reverse engineering problem in general when we're dealing with execution of software. Now, second stage execution partitioning is actually do the same process, but what you're doing with it isn't just actions, but you're now taking specific steps to try to mess up the target software. So an example. The open dialog box, you can type garbage in there and it won't know how to open a file. But what you type as garbage can make a difference. If you put % signs, you're going to get a whole different control flow than if you just use alphanumeric characters. Do we know why? Not really, but it certainly shows two different groups on the graph. So the data that you input is just as important as actually inputting the data. And I'm just showing off here that you can interact with that in WoW. Here's my dude. He's standing in front of the mailbox, and this orange node's over here, him actually clicking on the mailbox. I'm getting the mailbox code out of the way without actually doing anything yet, and then I actually interact with the subject line, and I quickly identify the code that specifically handles the subject line, those kind of lighter pinkish-looking blocks there. Keep in mind, this takes no time. I mean, this is like a couple of minutes, and I've already got this on the graph. So it's not just about packets, it's also about what you put in them. I think that's pretty clear. Third level is to actually cause an abortive condition while you're performing an action. So not just send in data, but send in the data, and as it's being sent in, pull out the network card and see what happens. You're going to get a whole new set of behavior. I'll give you a little example I have of doing different logins. So in this kind of mock-up, imagine that we have the general login processing on top, and then we type in the correct password, we get the orange, we do the incorrect password, we get the blue. But did we think of all the possibilities? Maybe not. Remember, we can get locked out if we do too many invalid attempts, and that would shoot off as the red. So an abortive type action, something to cause an error condition. This should give you as maximum code coverage as possible. Now that was all control flow related. Let's get into some even cooler stuff, which is the data sampling. What time is my talk over? Okay, I have to go pretty fast here then. The nice thing about doing the data after the code is that data follows code. It makes sense, right? Whatever the data is doing related to a behavior, it'll make sense that the code and the data coexist at the same time for that behavior in the CPU context, because the code is operating on the data. So all we have to do is follow the code and then do invasive, deep data sampling on sections of code. In other words, a single set, say the casting bar interaction. I may want to learn more about that. I could select just that set only and do a deep data flow analysis on that region. Now, because data flow tracing is so processor intensive, this is actually a benefit for us. We're not trying to data flow trace everything in the whole program. That would take hours and hours and hours just to get a single trace. We're just focusing in on a very small region, but we already know what that region's about, and we already know we're interested in that data. So the next example will be data sampling. This is a simple technique. We will go to a location of interest, say in the graph, and we're going to do sampling at every single instruction. The samples will have all the register contents, and then every one of those registers will be tested to see if it's a pointer. If the value stored in that register points to valid memory, we will take a 32-byte sample of that memory and bring it back over the TCP channel. We're not doing any processing of this data, we're just doing kind of raw data sampling without any real try to have any intelligence or anything to it. That's going to come back though, and we're going to do some searches on it. So let's say that this orange region here, the correct login is what we care about. We would select just that in the graph and turn on the invasive data sampling. Now once we have the samples collected, we can perform a search. We can search for all kinds of things. If you know a specific value you're after, say an XYZ coordinate in WoW, I could search for that as float values in the data sample set and quickly recover any location that was referencing that data. We could also do something a little more complex and do regular expressions. Maybe we don't know exactly how a SQL select statement will be set up, but we know that it'll have the word select, so we could use like a substring match or something.